Math 2414, Partial Fractions, Video 7, Example of Repeated Linear Factors. In this video, we're going to integrate the following rational function: x to the fourth minus 2x squared plus 4x plus 1 all over x cubed minus x squared minus x plus 1. Now, if you're watching this after having just watched the previous video, you might be thinking, this isn't what we did on the previous video. Oh, really? Let's just wait and see. All right, so if we're going to try to integrate this using partial fractions, there's two problems that need to be fixed. Number one is the degree requirement. Recall that in order to do a partial fraction decomposition, you need the degree of the denominator to be greater than the degree of the numerator, which it's not in this case. Since the bottom degree is not greater, we must do long division to get this ready. So our first order of business is a long division problem. And based on the size of this, it may look like it's going to take a long time to do. And the truth is, it's not going to take that long. The way you can gauge how long a long division problem will take is the difference in the degrees. When the degrees are close like they are here, 3 and 4, then it will only take a couple of moves. In fact, you can calculate or predict the number of times you have to repeat the division process by subtracting the degrees and adding 1. So if we subtract the degrees, we get 1. 1 plus 1 is 2. We're going to have to do 2 passes through long division. Warning, the numerator is missing an x cubed term, so we need to represent it. So let's get this set up. Almost put a plus where I needed a minus. All right. I had to pause for a second, so my apologies for any break in continuity in the dialogue here, or monologue actually. All right, so we're doing the long division problem, and we'll start by saying that x cubed goes into the x to the fourth x times. Or equivalently, x is what you multiply by x cubed, turn it into x to the fourth. Speaking of multiplying, let's multiply the entire divisor by x and write the result under the dividend. X times x cubed is x to the fourth. X times negative x squared is negative x cubed. X times negative x is negative x squared. And x times positive 1 is positive x. And then subtract. Again, if you struggle with long division, let me know. I have some videos from college algebra that goes into greater detail. All right, let's subtract. X to the fourth minus x to the fourth cancels. That was the whole purpose of figuring out what goes on top. 0x cubed minus negative x cubed is positive 1x cubed. Remember, we're subtracting. Negative 2x squared minus negative x squared is negative 1x squared. And 4x minus positive 1x is positive 3x. Then bring down the plus 1. And let's do it again. Now we ask how many times x cubed goes into positive 1x cubed. The answer is positive 1. So this one's easy because we're multiplying the divisor by positive 1, and multiplying something by 1 doesn't change it. 1 times x cubed is x cubed. 1 times negative x squared is negative x squared. 1 times negative x is negative x. 1 times positive 1 is positive 1. And now when we subtract, almost everything cancels. The x cubes cancel, the x squareds cancel, the 1's cancel. However, positive 3x minus negative x is positive 4x. So that's going to be our remainder that we put on top of the divisor. X cubed minus x squared minus x plus 1. That means that our integral can be rewritten as the quotient plus the remainder of the divisor. Now our integral is x plus 1 plus 4x over x cubed minus x squared minus x plus 1. We're not out of the woods yet. Let's take this to the next page. Now, I can integrate the first two parts easily and then worry about the fraction by itself. Let's go ahead and split this into three integrals. The integral of x dx plus the integral of 1 dx. We could have just written the integral of dx there, plus the integral of 4x over x cubed minus x squared minus x plus 1 dx. And of course, we can figure out the first integrals easily. They are 1/2 x squared plus x. Now we can focus on this integral. At the end, I hope I don't forget that I've already got part of the answer right here. All we have to do is evaluate the second integral and append it to the answer that we already got. So let's take this second integral to the next page, or this remaining integral, I should say, to the next page. At this point, the remaining integral is ready to integrate using partial fractions. The degree of the denominator is greater than the degree of the numerator. Now, it's almost ready to integrate using partial fractions, because in order to do a partial fraction decomposition on 4x over x cubed minus x squared minus x plus 1, we have to know what the factors of the denominator are, which means we need to factor the denominator. So let's see if we can factor this. I'm not going to spend a whole lot of time teaching factoring technique. This is a Calculus 2 class, but if you want to review, I do have a series of factoring videos. Ask me and I'll put you in touch with it. I would factor this by grouping, by thinking of this as two separate halves, two separate groups, and taking a greatest common factor of x squared out of the first group, leaving x minus 1. And it doesn't look like there's much to take out of the second group, but I'm going to factor out a -1, which would also leave an x minus 1. And then the grouping process continues by saying the common factor across the entire polynomial is x minus 1, and the remaining parts, the GCFs that I factored out initially, make up their own factor. But x squared minus 1 is a difference of squares and factors in x minus 1, x plus 1. Now we see that x minus 1 is a repeated linear factor. It shows up twice. So to move forward with the partial fraction decomposition, I have to factor the denominator, and it factors into x minus 1 squared times x plus 1. And at this point, if you watch the previous video, you may recognize that this is the fraction that we did the partial fraction decomposition. So let's go to the next page and capitalize on what its partial fraction decomposition was. From the previous video, we know that the partial fraction decomposition of 4x over x squared, 4x over x minus 1 squared times x plus 1 was 2 over x minus 1 squared plus 1 over x minus 1 minus 1 over x plus 1. Last two fractions can be integrated easily with natural logarithms. But to integrate the first fraction, we might want to rewrite it as 2 times x minus 1 to the -2 power, and then do a quick u sub on it. However, doing a quick u substitution on it is kind of pointless because the inside here is x minus 1, and its derivative is 1. So we could just integrate it directly. All right, so let's integrate these things. To integrate the first one, we just use the power rule. Add 1 to the power, which will make it -1. Add 1 to this power here, make it -1, and then divide by that new power. So 2 divided by -1 is -2, and adding 1 to the power makes it a -1. Again, we really don't have to do a substitution there, because if we said that u is equal to x minus 1, we would have du equals dx, which means that we don't have to balance anything, so we can just integrate as is. For the same reasons, we can integrate the last two without doing the substitution. The integral of 1 over x minus 1, is a natural log of x minus 1. natural log of the absolute value of x minus 1 minus the integral of 1 over x plus 1 is the natural log of the absolute value of x plus 1, and of course plus a constant. This is an okay answer. I would probably rewrite the negative exponent as a fraction since we started the fractions. So we'll write the first one as negative 2 over x minus 1. Now, you can leave the rest of it alone, but I am going to use an algebra rule called the quotient rule for logarithms. Basically, it says if you subtract 2 logarithms, you can condense them into 1 logarithm by putting the first argument on top of the second. But even this isn't our answer. That was the answer. But what you're looking at is the answer to this integral, but that integral was the tail end of this problem, and so we have to glue together all of our answers. So our final answer is going to be 1/2 x squared plus x plus the answer that we got there. So when we put it all together, therefore, the integral of x to the 4th minus 2x squared plus 4x 1 over x cubed minus x squared minus x plus 1, x, I'm pretty sure that was the original problem, yes, is equal to the answer that we got first, the 1/2 x squared plus x, added to the answer we got at the end of this one, which is right down here. Pull that negative off of that first fraction and put it in front. Get my answer here. There it is. Minus 2 over x minus 1 plus the natural log of the absolute value of x minus 1 over x plus 1 plus a constant, and that better be a good place to stop. I don't know if anybody will get this reference, but I'm starting to quote Michael Penn, who has an awesome YouTube channel of math videos. At the end, he always says, this is a good place to